Okay, we're skipping around a little bit. 5-6, we're talking about two triangles like we've been for a while now, but we're not going to talk about congruent triangles today. We're going to talk about inequalities in two triangles. So again, the inequalities, that word does not mean that these triangles are congruent. So we're going to talk about what happens when those triangles are not congruent. And I want to review the triangle inequality theorem for a second. Remember, the triangle inequality theorem was the story that I told you about the straws, right? So two sides of a triangle have to add up to be bigger than the third side of a triangle. So because of that theorem, because of that property, we can have uh, triangles with different sides for that third side. So for example, what I mean by that is, let's say I have two sides that are exactly the same. This side is congruent to this side, and this side is congruent to this side. The triangle inequality theorem says that third side just has to be bigger than the sum of these two. So for instance, if this was, I don't know, let's say this one was 7 centimeters and this one was 4 centimeters. Remember, the range is you add them and you subtract them. So that means that it has to be smaller than 11. That third side has to be smaller than 11, but larger than 3. So it could be, that third side could be anywhere in between 3 and 11. So because of the triangle inequality theorem, we can now have inequalities in two triangles. So let's say, for example, that I just rotate this just a little bit. I don't remember how to rotate. Let's see if I can. So I just rotate this side a little bit. Now we have, again, we have the same side. This is 7 and this one's 4, but this third side is a little bit different now. So if I connect that third side, let's talk about what happens. So this is the third side here. There's one third side and there's the other third side. Okay, well, if you see, this is an obtuse angle and this is an acute angle. And what happens is, since this angle is bigger than this angle, this side, this opposite side, is going to be larger than the side across from the shorter angle. And that's called the Hinge theorem. So the Hinge theorem says if two sides of one triangle are congruent to two sides of another triangle. So for example, this side was congruent to this side, and this side was congruent to this side. And the only difference is this kind of looks like SAS, right? It kind of looks like what we were talking about with congruent triangles. We have a side, that included angle, and another side. But again, we're talking about inequality. So these angles, these included angles, are not congruent to each other. Well, we can tell something about the side across from it looking at that included angle. So that's called the hinge theorem. And a hinge, kind of like a door, closed, swinging open and swinging shut. And we'll talk about that more in class, about why they called this the hinge theorem. So again, the hinge theorem, it looks like this. So if we have, and we can write this on our cheat sheet, if we have two sides that are exactly the same in two different triangles, so these two sides are congruent to each other, but the included angles are not congruent. So I'll say, let's say I call this angle A and this angle B. Let's call this C, D, and EF. Okay, so let's say I tell you that angle A is greater than angle B. That means that this side, because angle A is bigger, that means side CD has to be, the length of CD has to be larger than the length of EB. That's what the Hinge theorem says. And converse, remember the word converse just means to flip it. So if we flip that, now we're not talking about side lengths. Our conclusion is going to be about angles. So we're exactly flip-flopping this. So this one says, if we know two sides in a triangle are congruent, so this side's congruent to this side, and this side's congruent to this side. And we'll call these the same triangles. So we have CAD and, oh, whoops, how did I put EBB right here? My bad, EBF. Whoops, well, that means that this is EF. Sorry about that. Okay, so we'll call this triangle EBF this time. because EBB does not make sense. Okay, so converse is just the flip of this. So this time I don't know anything about the angle measures, but I do know about that third side length. Those third side lengths are not congruent to each other. So let's say CD looks longer to me than EB. So let's say we know that the length of CD is larger than the length of EF. Well, that tells us about the those included angles. Oh, so if CD is larger, that means that this angle has to be bigger. And if this side is shorter, then this angle has to be smaller. So I can conclude from the converse of the hinge theorem that angle A would have to be greater than angle B. The measure of angle A is greater than the measure of angle B. Sorry. Measure, because we're talking about numbers. Okay, so that's the hinge theorem, and that's pretty much what we're talking about today. And we're going to use these in proofs later on. Yay! Okay, so what does that look like? How can we use the hinge theorem and the converse? So it says, what can you conclude in the following exercises to justify your response? So tell me, are you using the hinge theorem or are you using the converse of the hinge theorem? So here I have two triangles. Again, it's important for both the hinge and the converse that you have two sets. We need two sets of congruent sides. If you don't have two sets of congruent sides, you cannot use the hinge theorem or the converse. So that's the first thing I want you to think about. Show me, see. Okay, well, I have AB is congruent to AD, and I have, by the reflexive property, AC is congruent to itself. So I can use either the hinge theorem or its converse. This one tells me about side lengths, so that means I can talk about the angles. So what I can conclude by the converse, because I know the side lengths, so the converse of the hinge theorem, I can tell that angle BAC, measure of angle BAC, has to be larger than the measure of angle CAD. Okay, so again, if they tell us all the side lengths, then that's going to be the converse, because we can talk about the angles. Same for this one. Let's see if we have two sets of congruent sides. So here's a set of congruent sides, and then again, by the reflexive property, we know we have two sets of congruent sides. Sweet, check. So it's either going to be hinge or converse. Converse tells you about the angles. We can conclude, we can infer, we can conclude about the angles. Let's see if I can write this nice for you guys. So the difference between the hinge and the converse. Hinge tells you about angles. Converse, they tell you about sides. So what does that mean? You can conclude. I'm going to erase this, sorry. So that means for the hinge, if they tell you about the angles, therefore you can conclude about the sides. You can, what is that called? You can compare sides. How about that? Compare sides. And for the converse, if they tell you about the sides, that means therefore you can compare angles. Okay, cool. Maybe that'll help you guys out a little bit. Okay, so this one, they told us about the sides. They told us about the sides, therefore we can compare the angles. So again, for this one, we're going to use the converse of the hinge theorem. And let's see, since this side's greater, that means this angle has to be greater. So measure of angle FGE, this angle, FGE, has to be greater than the measure of angle EGH, because 9 is smaller. Okay, let's see. This one, they tell us about the angles. Oh, sorry, do we have two congruent sides? Sorry, I'm getting ahead of myself. 9 is congruent to 9. By the reflexive POC, yes, we have two congruent sides, so we can use the hinge theorem or its converse. Since they tell us about the angles, we're going to be using the hinge theorem this time. And let's see, I know 65 degrees is greater than 64 degrees, so that means side BC has to be larger than side AB. Right, and we can do the same thing for this one. This one, I like this one because we have to use linear pair. If this one's 82 degrees, this one has to be 98 degrees because remember they add up to be 180 degrees. And let's see, we have two sets of congruent sides. We know those two are congruent, and we know this one's congruent by reflexive POC. Let's see, since they told us about the angles, we can compare the sides. So I know I'm using the hinge theorem, and I know 98 degrees is larger than 82 degrees. Therefore, I can conclude that FG, side length FG has to be larger than side length EF. Okay, so that's really how you're using the Hinge theorem and the Converse. We're going to, let's see, how much time has it been? All right, it's been almost 10 minutes, so I'll stop. But know that in class, we're going to have to, we're going to show how to solve, and we're going to be using proofs. So that's something to look forward to tomorrow, and that we're going to add on to these notes for. Fun fact of the video, before we're done here, fun fact of the video, did you know an elephant's tooth can weigh as much as a bowling ball? A bowling ball! That's really, really, really heavy. And let's see, what you guys need to do tonight as stated on your calendar is you need to do page 343, and you need to do numbers, I believe it says numbers 2 through 5. So you are responsible for finishing 2 through 5 tonight. And I realized just right now that you need to know the last part. Sorry, guys. Last thing I'll show you guys, solving using the Hinge theorem and its converse. Basically, I want you to solve for a variable. So this is where you can do some fun algebra. We know these sides are congruent and these sides are congruent. So since I talk about sides, we can use the converse of the Hinge theorem. Sorry, I thought we were almost done. So I know, let's see, I know that 19 is larger than 18. So I know that 38 degrees has to be larger than the 5k minus 12. This is just one way you can do it. And then we want to solve for k. So I'd have to add 12 to both sides. And then I get 5k, the greater than sign, and I believe this is 50. And then when you divide both sides by 5, you're going to get 10 is greater than k. And that kind of sounds weird to me. So I'm going to reverse everything, and I'm going to say k has to be less than 10. But we're not done yet, because it doesn't make sense to have negative angle measures, right? So I also have to take this, and I have to say, so this is the first part. The second part is you have to say, okay, well, I know this has to be a positive angle. So I have to say 5k minus 12 has to be greater than 0. It wouldn't make sense to have anything less than 0. So I'm going to add 12 to both sides, and then I'm going to divide by 5. And it's okay to have decimals. We're going to have some decimals in this chapter, and that's totally fine. We like our decimals and our fractions. So we have k, is greater than 12/5, which I think is about, correct me if I'm wrong, I think that's about 2.4. So we have two answers, and we're going to combine these into a compound inequality. So our final answer is going to be that k has to be smaller than 10, but it also has to be larger than 12 over 5, or 2.4, I think. This could be wrong. I did that in my head. So this is a compound inequality, just like we did with the triangle inequality theorem, or finding the range of that third side at the very beginning. So again, this says that it has to be bigger than 12/5, but smaller than 10, and that's how you find the range. And that'll help you out on this page again with 4 and 5. All right, thank you guys for bearing with me, and I hope you learned a little bit about the Hinge theorem today.